In this video, we're going to learn how to add and subtract radicals. We can add or subtract radicals provided they are like radicals. In other words, they must have the same radicand, which is the number on the inside of the radical, and they must have the same index, which tells us which root we're working with. Here we have square root of 2 plus 3 square root of 2. The square root of 2 has an understood coefficient of 1. So 1 square root of 2 plus 3 square root of 2 equals 4 square root of 2. Now it may not be obvious that you have like radicals in some cases until you simplify the radicand. Suppose we have 5 square root of 3 minus square root of 27 plus 2 square root of 48. We need to simplify our radicals to see whether they are like radicals or not. So we have 5 square root of 3 minus, and I can rewrite the square root of 27 as a product of its primes, prime factors, 3 times 3 times 3, plus 2 square root of, and if we were to do a prime factorization on 48, we would get 2 times 2 times 2 times 2 times 3. Now since I'm working with the square root, I'll look inside my radical to see whether I have pairs. Each pair represents a perfect square. Here I have 3 times 3, which is 9, a perfect square. The square root of 9 is 3, so I bring that in front of the radical, and I'm left with the square root of 3 on the inside. Plus, now I have a 2 on the outside, and then I have 2 times 2 and 2 times 2 again. Well, multiplying all of those together gives us 16, and the square root of 16 is 4. So we bring that out in front of the radical. And it's going to multiply with the 2 that was already out front. So if we clean this up a little bit more, we have 5 square root of 3 minus 3 square root of 3 plus 8 square root of 3. We have 3 like radicals. Therefore, we can add and subtract. 5 square root of 3 minus 3 square root of 3 equals 2 square root of 3. 2 square root of 3 plus 8 square root of 3 equals 10 square root of 3. Let's take a look at one more example that's a little bit more involved. Suppose I have 2 times the cube root of 81 x cubed y to the 4th plus 3 xy cube root of 24y. Since I'm working with cube roots, I want to find any perfect cubes inside my radical and take those out. You can do a prime factorization on 81, and that will give you 3 times 3 times 3 times 3. Then we have x cubed and y to the 4th plus, then we have our 3xy cube root, and prime factorization on 24 would give us 2 times 2 times 2 times 3, and then times y. So now I'll look to see whether I have any perfect cubes. 3 times 3 times 3 represents a perfect cube. X to the 3rd is a perfect cube. And y to the 4th contains a perfect cube with 1 left over. And my second radical, 2 times 2 times 2, is also a perfect cube. So now I have 2 times, and I take this perfect cube, 3 times 3 times 3, the cube root of that is 3, and I look at my index, which is 3. and I see how many times does that divide into my exponent of x. 3 divides into 3 one time, so I can take an x out of my radical. I look at my index. 3 divided into 4, which is the exponent for y, divides in one time, so I can take out a y. And then whatever I have left over simply stays inside the radical. That would be 3 and 1y. 3y. Now I evaluate my second radical. I have 3xy out in front. The cube root of 2 times 2 times 2 is the cube root of 8, and that's 2. So I pull that out, and I'm left with the cube root of 3y. Now I multiply the numbers out in front of the radical. 2 times 3 equals 6, and my variables x times y give me xy. So I have 6xy, cube root of 3y, plus, and here I multiply 2 times 3, that gives me 6xy, cube root of 3y. Here, I see that my radicands are the same. That means I have like radicals. I'll add the coefficients in front. 6xy plus 6xy equals 12xy times cube root of 3y. So that's it for these examples. Hopefully you have found them helpful, and we'll see you next time.